Hi ladies and gentlemen, it's Mr. Elting here again, here to help you with tonight's homework. I'm talking to you about number 6 right now, which is a question about Mr. and Mrs. Elting leaving work. I have a similar problem here. Yes, this is the dreaded chart problem that you all fear, hopefully come to cope with. And I just want to write some things out. I'm going to actually just copy the chart from the homework page. We have rate, time, and distance in this case. This is actually the distance formula. And I didn't write this on your sheet, but you might want to know this. When you multiply the rate that something moves by the amount of time that it takes, that does give you its total distance. We're going to use that fact to write our equation at the end of this problem, but let's try a slightly different problem than the one I gave you. Let's talk about John and April. Okay. With any chart problem, remember we talked about this a little bit earlier today. The first step is always draw a comparison. In other words, try to read the problem and notice if there are any obvious comparisons between two people or two things, because that's probably a good jumping in point for the problem. And what I see here, I see 4 seconds later. That is a comparison between John's time and April's time. Now, I don't know how long John actually travels. It doesn't give me any information about how long he is in the air when he leaves. So I'm just going to call his time X, or T, if you prefer. But I'll tell you what, I know what April's is, because April is a comparison to John. 4 seconds later. If she is leaving 4 seconds later, that means she's going to be in the air 4 seconds less time. I know this one's a little weird. You might be tempted to say X plus 4, but think about it. If April leaves 4 seconds later, she's going to be in the air for 4 less seconds than John is. John is actually going to be in the air for 4 more seconds, because in those first 4 seconds, April hadn't jumped yet. So that's a little weird to think about. It's a little backwards, but if you can get over that for this particular problem, the rest of it's not too bad, because we know our rates. The rate that John travels, well, that's 30 meters per second. And the rate that April travels, well, that's just 40 meters per second. And now that I know those two facts, to get my last column, I'm just going to multiply straight across. What's 30 miles an hour times 30 meters per second times x? Well, I don't know what x is, but I can still multiply to get 30x. Same thing here. I don't know how long April's in the air, but I can still multiply x minus 4 by 40, use the distributive property. You get 40x minus 160. So here's the last piece of information that you need to figure out. When John and April are caught up to one another, how far are they in comparison to the plane? And the answer to this should be equal. They should both have traveled the same distance. Now, April traveled that distance faster than John because it took her less time, but they have traveled the exact same distance. So in this case, that is actually where our equation comes from. John traveled 30x, whatever x is, and April traveled 40x minus 160. And now that I have this, I should be able to solve this equation and find out exactly how long it took. I think if I just solve this really quick, minus 40x from each side, you get negative 10x. And negative 10x is equal to negative 160. When I divide by negative 10, I should get positive 16. So it looks like x was 16 seconds. And if I go back here into my table, I'm just going to use red to show this. John, since he took x, he must have been in the air for 16 seconds. Since April left 4 seconds later, she must have been in the air for 16 minus those 4 seconds is 12 seconds. It took her 12 seconds to catch up. And this problem, number 6 on your homework, it's very similar. I know the time thing is a little confusing, but think about it this way. Who has to drive the longer amount of time? that's the person we're going to be adding to. Or if you want to think about it the other way around, who's the person driving for less time? That's the person we're going to be taking away from, okay? In this case, this problem wasn't too bad. Please note that, again, the distances are equal since one is catching up to the other, right? The distances are equal. Someone travels a certain distance, the person travels it a little bit faster. Either way, when they catch up, they've traveled the exact same distance. If you need any more help, please let me know. Shoot me an email or submit a question online. I'll be honest with you guys, since it's my birthday today, I might not check it right away, but I will try before I go to bed to do so. Thanks, guys.